the second important thing you must have to understand, 0 is both purely imaginary, you can say purely imaginary, as well as purely real number, right? So 0 is also a complex number which is purely imaginary as well as purely real number. How? Let's say 0 plus 0 times I. In this case, this is 0 will multiply when this I or iota, this whole part is going to be 0, that can be neglected. At that time 0 becomes just like a real, just like a real. And if you are considering this as a 0, this as a nothing, when you think this is nothing, this part is nothing, then that time this will work just like a complex number, just like an imaginary number. All right, so depends what you're thinking. So when you first think this imaginary part as a 0, nothing, that time this will work as a purely real number. And when you consider this real part as nothing, 0, that time this work as a purely imaginary. So that's why 0 is can be said to be both purely imaginary as well as purely a real number, right? Now the third very important thing you need to understand, in the case of purely imaginary number, the real part must be equals to 0, but imaginary part may or may not be 0. All right, so in the case of purely imaginary number, real part must be 0, it's always 0, but imaginary part may or may not be 0. let me show you here. Like let's say it's completely imaginary number. All right, so it will be 0 plus 3i. In this case, where you're looking, the real part is completely 0, but the imaginary part is here. Yes, it is existing here. Imaginary part is existing, but sometime I said 0. Next concept you must have to understand is, let me write it here. Every real number is purely real. Every real number is purely real, and purely real number is always real number. Quite confusing. All right, so what I mean that every real number, let's say 2 minus 3 minus 0.55, whatever you say, these all are purely real number, because the imaginary part is not existing here. 2 plus 0 times I, if you do, means this is nothing, so it's purely real number. Keep in mind, I mean to simply say that a real number, like this real number is purely real, right? Purely real. And if anywhere if you see any purely real number, that's definitely a real, that's definitely a real, or simply say real number, whatever you say. All right, but imaginary number may be purely imaginary or may not be, and there is one purely imaginary number which is 0. And next thing, 0 is not imaginary. All right, 0 is not imaginary. It's quite interesting. See, every real number is purely real. All right, and every purely real is a real number, but imaginary number may or may not be purely imaginary. And there is only one purely imaginary number, which is 0, and 0 is not imaginary number because 0 exists. So from here, one more thing we get to understand, that imaginary number do not exist. All right, imaginary number do not exist, but they really have a very, very great use in mathematics. A great application we have of complex number or imaginary number in our mathematics. All right, so this was a short brief about the complex number, and later we're going to learn more and more about this. All right, so please subscribe the channel, hit the like button on this video, and I'll see you in the next video. All right, goodbye.
मुकेश जी, इस पॉलिसी में प्रीमियम खत्म होते ही आपको एक अच्छी रकम मिलेगी।
I like it. चल साइन कर। एक मिनट, इसे बहुत अच्छे से जानता हूँ मैं। ये सब उड़ा देगा, और फिर मुझे कुछ हो गया तो मिसेस मुकेश का क्या होगा?
डोंट वरी मुकेश जी, आपको पैसे मिलने के बाद भी आपका लाइफ कवर 100 साल की उम्र तक चलता ही रहेगा।
क्या? साइन कर। एक मिनट तो क्या इसके लाइफ कवर का प्रीमियम मैं भरूंगा।
पहली रकम मिलने के बाद कोई प्रीमियम नहीं देना पड़ेगा मुकेश जी।
वो क्या देख रहा है बे? चल साइन करवा, चल साइन कर। अरे करने दोगे तब ना।
IDBI फेडरल लाइफ इंश्योरेंस होल लाइफ, बेफिक्र उम्र भर।
तू मीठा मत खा, इससे डायबिटीज हो जाएगी। फिर मैं मीठा कैसे खाऊंगा?
After learning a little concept of complex number, let's talk about the equality of two complex number. For a while, let's say I have a complex number Z1, which is A1 plus let's say I times B1, and similarly, let's say I have another complex number Z2. That time, let me imagine this is complex number A2 plus I times B2. All right, so these are two complex number. So when can I assume that these two complex number Z1 and Z2 are equal? Let's say Z1 and Z2. So what is that condition when Z1 and Z2, I mean the two complex number, get equal? So I'm just doing, all right, I'm just checking out I'm just trying to find out the two conditions. For a while, A1 plus I B1 equals to A2 plus I B2. All right, and now what I'm doing, I'm writing A1 and I'm bringing this A2 into left hand side, so it will be A2. All right, and here I have I times B2, and this IB1 is getting into the right hand side, so it will be I times B1, and further it's A1 minus A2 equals to, now I'm taking here I and I, so I can take easily the common. All right, I get common, so it will be I B2 minus B1, and now I'm going to square both sides. All right, squaring both sides. So we'll get here now A1 minus A2 whole square, and it will be I square. All right, I iota square, and it's B2 minus B1 whole square. Further, if you look, it is now A1 minus A2 whole square, and iota square, that's minus 1, because we know this, I square equals to minus 1, and then it's B1 minus B2 whole square. Further, A1 minus A2 whole square, and this this is minus 1, so when it will come, this will be plus. And now B1, it's B2, not B1. All right, it's B2 minus B1 whole square equals to 0. Now take a look very seriously on this condition: A1 minus A2 whole square plus B1 minus B2 whole square. So this is only possible when this part is 0 and this part is 0. It means A1 minus A2 whole square is 0, and which gives finally us A1 minus A2 equals to 0, and that leads to A1 equals to A2. And from this second condition, we have B2 minus B1 whole square equals to 0. That gives us B2 minus B1 equals to 0, and finally that leads us to the B2 equals to B1. So here we get the condition when two complex number gets equal. So if A1 equals to A2 and B2 equals to B1, and that time if this condition exists, then I can say that the two complex number Z1 equals to Z2. If the real part of the both complex number is equal, and similarly the imaginary part containing real number B1 is equals to B2. So this is the condition of two complex number when they get equal. All right, and one thing, let me tell you, my friend, when the imaginary part of the two complex number, it's B1 and B2, I'm talking about these two things, if these are non-zero, then that time it's very difficult. You cannot compare the two complex number, whether Z1 is greater than Z2 or Z2 is greater than Z1. I mean let's say Z1 equals to 4 plus 3i, and Z2 equals to, let's say, minus 3 plus 2i. So how can you say Z1 is bigger or Z2 is bigger? You cannot compare which one is bigger or smaller. I'm not talking about the absolute value. All right, I'm not talking about the absolute value of Z1 and Z2. I'm not talking about these two things, if you're remembering. All right, simply I'm saying the value. I mean the Z1 or Z2, which one is bigger, which one is smaller. I cannot figure out. It's a we need to learn in higher level of complex number. All right, at present time, simply I want to tell you, we cannot determine which trigger